Hello, hello. Yes, we would like to welcome you back again. This is Physical Sciences Silver Bullet, which is acronymized as PSSB. So the name behind is Richard. So today we are looking at this question. We are looking at this setup where we are having a hydrogen half cell here connected to unknown half cell here, and the voltmeter reading is 0.8 volts. This is the setup we are having, and we are going to look at a series of questions which can come on this setup. Okay, let us look at the first question which comes. It says, state the type of electrochemical cell above. We have to be reminded that there are two types of cells. One is electrolytic cell, which we saw in detail during our previous videos, and the other one is galvanic. So which is this? This cell is a galvanic cell. Okay, somebody might ask, why do we say it's galvanic? When you look at this setup, we don't have a battery anywhere. We have two half cells and we don't have a battery anywhere. And that's evident that the energy which runs this cell is coming from the cell itself. It does not come from external source. So that makes it to qualify as a galvanic cell. Then comes the second question. It says, state the standard conditions for the cell above. So when you look at this setup, what are the standard conditions? Okay, like we discussed before, there are three standard conditions. And the way we have this cell, all of them apply. Okay, let us look at them. The first one is that the concentration of these electrolytes is concentration of 1 mole per cubic decimeter. That's one of the conditions which makes this cell which is a standard condition. Then the other condition is the temperature. The temperature of the environment in which the cell is set is 25 degrees Celsius or 298 Kelvin. Now, the third condition, which sometimes apply to some cells and not, it will apply to this one, because this condition comes when you have a gas involved. So in this case, we have the gas involved. We're having hydrogen entering here. So that's the condition. So it's supposed to be pressure of the gas. If the gas is involved, pressure of the gas is 1 atmosphere or 101.3 kilopascals. So these are the conditions or the standard conditions for this setup. Then comes this question here. The question says, write half reaction at anode. Now, for this particular cell, you cannot afford to answer this question not until you have the ability to interpret these signs here, the positive and the negative. We must recall that for electrolytic, the cathode is negative and the anode is positive. The opposite is the case in this case. So in contrary, for galvanic, the positive is our cathode and the negative is our anode. So that must be noted seriously. I repeat, for galvanic, positive is the cathode. That is in contrary to what we saw in electrolytic. And negative is anode. So this question wants us to write reaction at anode. We have to remember also that whether the cell is electrolytic or galvanic, the reaction taking place at anode is oxidation, and the reaction taking place at cathode is reduction. That one is the same, but the signs are different, and that one must be noted seriously. So, what is our anode? Our anode is our hydrogen here. This is our anode. Okay, and what reaction occurs at anode? That one is the same, whether the cell is electrolytic or galvanic. The reaction at anode is oxidation. And what do we know about oxidation? You can use several definitions, but here we can capitalize on the loss of electrons. So if we are going to lose electrons with hydrogen, this is what we must have. Okay. We have a hydrogen gas, losing electron to give you hydrogen ions. From the look we have here, it is apparent that this one is not balanced. So we have a 2 here and we're having 1 there. So this necessitates the putting of the 2 here. And that one also helps us to know how many electrons are involved here. So the electrons are going to be 2. What we are having here now is the reaction at anode. Then comes this question, a reaction at cathode. Like we said, this one has to be taken seriously. The cathode of a galvanic cell is the positive. So this side here is our cathode. Now we have a scenario here. We do not know what A is. So we are going to use the same symbols we are having here to accomplish that reaction. But there's some information which is very important before we write. We don't know the symbol of the element, but we know that the element involved is having a cation with a +1. The valence of that element is 1. So that one highlights the number of electrons which are involved. So, and also have to remind you that whether it's galvanic or electrolytic, the reaction at cathode is always reduction. So what is the reduction involving A? Sorry, reduction, we are having the A ions which gain that electrons to become reduced to A. That is the reaction taking place at cathode. Then comes this question. The question says, write the cell notation of the cell above. So what is the cell notation here? We need to be reminded of what we did during our notes, which were posted in the videos. We said that for cell notation, this side, which is the left-hand side, is the anode, and the right-hand side is the cathode. Now, what is our anode? Our anode is this one. This is what we experienced at anode. So we start by writing H2. Then you bring in the phase difference. Then you bring in hydrogen ions. It is very important to realize that we don't bring the numbers which are there, the twos. So we are having now the aqueous solution. Then comes the salt bridge. And after the salt bridge comes our cathode. The cathode is also written the way it is. So we are having A ions, which are also in aqueous solution. You bring in the phase boundary, and you have A. A is a solid. This cell notation is incomplete. We have to remember that what is at the extremes of the cell notation are the electrodes. So this one is okay, but we have a problem with hydrogen being the last one, because a gas cannot be an electrode. So under this circumstance, you are supposed to bring an electrode, or you can put graphite, or you can put platinum. Now, this is what we have as our cell notation. You have to be reminded that cell notation represents the way the cell is arranged, but without the diagram. Now, after this question, remember, we don't want to make long videos. We don't want to bore you. So we are going to cut this video here, and we see further questions in our next video, part 2. So don't hesitate to subscribe, and also to like, and to comment, and to ask questions. Don't forget the channel is Physical Sciences Silver Bullet, which is acronymized as PSSB. So the channel is PSSB, Physical Sciences Silver Bullet.